Good morning. Can you hear me?
Good
Hello?
morning, sir.
Good
Okay.
morning,
Good morning.
sir.
Good morning.
Good morning,
Alright.
sir.
Yes, sir. Good morning.
Do you have any question from the last class? Okay. So today we will discuss a new topic, which is how much I will cover today. Let's start this topic. Okay, I hope this is visible. This whiteboard is visible to you.
Yes, sir.
Yes, sir.
Yes,
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 sir.
sir. Yes, sir.
Today's topic is we'll start this topic, dimensional synthesis. Action. What is the lecture number? 7, right?
7, sir.
Okay. This is our lecture number 7, and we will start today dimensional synthesis. What we do in this under this topic, let me write down that determine. This topic is related to determination of kinematic dimensions. Kinematic dimensions, like what are these kinematic dimensions? Like link lengths, offset, this kind of dimensions of the mechanism of the mechanism to satisfy the required motion characteristics. To satisfy the required motion characteristics. Okay. And this is classified into classification of this topic is number 1 is motion generation. Second is path generation. Third, we will discuss function generation. We will discuss the graphical methods for these dimensional synthesis problems, and this is called dead center problem. So, what actually want to do? Suppose there is a mechanism, and that mechanism has to satisfy a particular kind of motion, required motion characteristics. To ensure that motion characteristics, you would need to define what should be the length of the link, what should be the offset, and other things. Okay, all the geometric aspect of the mechanism we need to define, and for that, these are the four categories we will discuss. All of them are graphical methods, and these graphical methods we'll discuss here. Mm, So, what is called a motion generation problem? The four kinds of problem: motion generation, path generation, function generation, and dead center problem. All are these required motion characteristics. Here you see required motion characteristics for a mechanism. It is classified to solve this kind of problem. The problems are classified into these categories: motion generation, path generation, function generation, and dead center problem. What is a motion generation problem? A rigid body can be guided in a prescribed manner. This is a problem where a rigid body can be guided in a prescribed manner. Okay, so what does it mean? Suppose we have a four-hour mechanism like this, four-hour mechanism like this, and your client asked you that the coupler must have positions like initially he want the position of the coupler is here, this configuration, and the next after some time it should be here, and finally it should take a position like this coupler. It is required to, so this is the position 1, this is the position 1 3, 2, and this is the position 3. These three positions are required. This is the requirement of the mechanism, and it is decided that this configuration will be given by this four link mechanism. Now you have to find out where should be this hinge points, where should be these support points. Let's say this is O2 and O4. Okay, where should be these points? Then this kind of problem is called motion generation problem. In this case, see, only what is specified. Specified is this position, this position, this position, and this position. So in a guided the rigid body is the coupler here, and it is a prescribed manner. The rigid body motion is now rigid body, its motion is prescribed here this way. Then the problem is you have to find out where should be the hinge points, and also you need to find out where should be the connecting points. Suppose this point is A and this point is B. So in the coupler is a rigid body. you can have this point A is here and point B is there, or you can have point A is here and point B is there. Okay, so you need to find out where should be this point A and B, so that the whole mechanism when moving will give you this kind of motion. That is called path generation motion generation problem. In path generation, a point on a link, a point on a link to be guided along a prescribed path. A point on a link to be guided on a prescribed path. So again, if we take an example of a four link mechanism. Again, we are taking an example of a four-link mechanism. Now, your requirement, somebody has given you a requirement that a point on the coupler, suppose I take a point on the coupler like this point, okay? Also, you can have any shape of the coupler. Suppose the coupler is of this shape. Okay, on this coupler there is a point here, and that point has to move on a prescribed path. Suppose that prescribed path is this prescribed path. When the mechanism is having motion like this, and the prescribed path, the point C, suppose this is point C, the point C must follow a path like this. Okay, and to ensure the motion of this point C along this path, we need to design the mechanism. Design the mechanism means, so these points, what is in your hand, you can define what should be the length of the coupler, what should be the length of this crank and follower. Okay, all these things you can decide, and you can also decide where should be this grounded hinge points, right? So to actually what you are finding out here, if you can find out these 4 points, then the problem is solved. Then you know what is this distance, what is this distance, and what is this distance. All those things you have to actually find out to ensure this path for the point C, which is on the coupler. So this kind of problems are called path generation problem. And remember that all the problems we will solve here using only four-link mechanism. Okay, now the third category is output and input have a functional relation. When the output link and the input link input have a functional relation, for example, you just again let us consider a four link mechanism. For example, again let us consider this mechanism. Suppose we have a mechanism like this. Right now, when you move this one of the link to in this direction, so there should be some motion here. But suppose you want that the motion of link 1 here, this motion of link 1, say its rotation is given by theta 1, sorry, theta 2, maybe. Rotation of this link 2, if you give numbers 2, 3, 4, rotation of this link 2 is given by theta 2. So you will have some rotational motion here in link 4, that is, let's say, theta 4. Now, if for some application, this theta 4, if this theta 4 is a function of theta 2, then that kind of problem is called function generation problem. Okay, where this theta 4, the output, is a function of input. In that case also we can find out the link lengths, okay, the kinematic, all the kinematic dimensions, so that it can ensure this motion. This kind of problem is called function generation problem. Okay, the fourth one is the dead center problem. This is to actually generate a prescribed this is to generate a prescribed dead center configuration. What is a dead center configuration? Dead center means the extreme positions of a mechanism are called dead center, and sometimes we need to ensure a particular extreme position. So the extreme position, with respect to the extreme positions, you sometimes find out what are the link lengths and all the kinematic dimensions. Those problems are called dead center problem. Slider crank mechanism, for a slider crank mechanism, you know that they suppose the slider can move from this point to this point, from this point to this point. So these 2 points are actually two extreme positions. Two extreme position. This is the slider, motion of the slider, and these two are the extreme position. So these two extreme positions will be satisfied when, suppose, you have, this is the uh, sorry. So this is the coupler, and the crank is here. Okay, this is the hinge point, and at some other point of time, so the other dead center would be like this. So this is the crank position, this is the coupler, and this is the crank. It is maybe rotating in this direction, and these are the two dead centers we have shown here. Okay, so these are the four types of problems we will discuss within this topic, dimensional synthesis. And as I said, for the introduction, this is only introduction level, so we will be solving only 4 link mechanism problems. Okay, now some other definitions we must discuss here, which is called, there is something called precision point or accuracy points. Precision points, or it is also called accuracy points. Precision points or accuracy points are those points at which generated and desired functions agree. These are the points at which generated and desired What do you mean by this generated and desired points? Suppose you take one you take one example. Suppose I take this path generation problem where you need to ensure the couplers a point on the coupler C must follow a path like this. This path must be followed by a point C on the coupler. Okay, but we will discover that it it is not very easy to ensure this that the C at all positions of this mechanism of this four link mechanism when it is rotated, it is very difficult to ensure that C is following a particular desired path. So then what happens, we ensure at a particular few at some points, suppose at these 3 points, point 1, 2, and 3, at these 3 points, the mechanism which we have now designed, suppose the design we have that follows the C point follows a path like this. Okay, so this is the desired path and this is the path which is generated path. Desired path means you have given, this is the requirement, and generated means after you have designed the mechanism, this is the path the C is following. But see, these two paths are not exactly same, but they are intersecting at some points. That means these two paths agree at these 3 points. These 3 points are called accuracy points or precision points. So what is the significance of this accuracy point or the precision points? So when you have a requirement of this kind of design, then always it is specified that at these points, the generated mechanism, the designed mechanism must satisfy the requirement. Okay, so these are called accuracy point or precision point. This is something called approximate synthesis. Approximate synthesis. So already we have discussed there when the generated motion when the generated motion fits with the required motion at a finite number of points. So already we have discussed here that when the generated motion, this path is the generated path, is agreeing with the desired motion at some points. Okay, this number of points. Then this kind of analysis is called this kind of synthesis. Synthesis means the dimensions which we obtain from the requirement. This kind of synthesis is called approximate synthesis. There is also something called exact synthesis when the desired and generated functions uh, agree exactly. That is called exact synthesis. I'm not writing that definition. When the desire and require, they they required and generated, they exactly agree. That is called exact synthesis. Okay. Now, without spending much more time, we want to go to the graphical methods. So first we will discuss motion generation, and we will mostly we will discuss three position synthesis. That means here we have already discussed that precision points. When there are three precision points, as I have given here example, this is called three position synthesis problem. Okay, or 3 point synthesis problem. And obviously that is a approximate synthesis problem. So we'll start with this motion generation, three position synthesis. Before we go to discussion, we need some discussion on inverted motion. Okay, so what should I do first? Let me discuss the problem, then we will go for what is called inverted motion. So suppose as I discussed, already discussed in the beginning, what is a motion generation problem? Suppose three position of a coupler given. Let three position of a coupler is given, and these three positions, suppose these three positions are any position you take. This is position 1 of the coupler, this is position 2 of the coupler, the same coupler, and let's say this is the third position of the coupler. We will call this position first position, second position, and third position of the coupler. Okay, so these three positions are given, and we have to find out this synthesis of mechanism. Means we have to find out lengths of the links, like link 2, link 4, and the distance between, or positions between O2 and O4. So suppose for a generally the notations we use, this is O2, the hinge point here, link 2, this is the coupler, and the fourth link is the follower, and this is O4. So we need to find out where is this O2 and O4 with respect to the coupler, so that we can find out what is this link length 2 and link length 4. Okay, so there is a problem in this problem. Uh, this problem, suppose this point A and B are given to you. Okay, then you have to find out the O2. So for three positions given, then obviously from the second position you know what is the what are this hinge point. This is this point is, let's say I am calling A1, B1, second position say A2, B2, and third position say A3 and B3. This is given. Okay, so what we need to find out is so determine the position of O2 and O4. If you can find out O2 and O4, the problem is solved. You can find out what is the link length and relative position of O2 and O4 with respect to the coupler. The problem is solved. Now, how to solve this kind of problem? So, so in this case, you see the points, three positions are given. So we know actually the positions of A1, A2, and A1, A2, and A3, and B1, B2, B3. Right? These three, since these three position of the coupler known to you, so that means A1, A2, A3, these 3 points are known to us, and B1, B2, B3 are known to us. We are assuming that these points are not collinear. This one and these 3 points, they are not collinear. Okay, if they are collinear, then some kind of problem is there. But we are assuming that these 3 points are not collinear. Our aim is to find out, determine the position of O2 and O4. How to find out O2 and O4? For example, you just go back to this mechanism here. Suppose at this point, this is the second position which is I have drawn here. Suppose this is the second position, and for the first position, and the A point was, let's say, here A1. This is A2, and the third position is, this is A3. Now, for all these from points A1, A2, A3, what is the relation with this O2 point?
At
What is
equal
the
distance.
relation with? Huh? Huh?
At a fixed distance.
At equal distance.
Yeah, say they would lie, they to A1, A2, A3 must lie on the same circle, right? Same arc.
Yes.
Okay. So now suppose for any problem, this A1, A2, and A3 is given. How to find out the center? A1, A2, and
By
A3.
joining
This
any 2 points, and
bolo,
so we will find the mid.
bolo.
So it's centroid is the center.
So how to find out the center? It's very simple. Suppose we have 3 points A1, A2, A2 and A3. How to find out the arc on which
We can
Sir, we
draw a
will
chord,
join
sir.
all the
you can draw?
yes,
Chord.
and
So what you can do, you can draw a, just join these lines, and then you can draw perpendicular
Bisector.
bisectors.
Yes.
Okay. So if you draw perpendicular bisectors from this, you can get this point. So this point is then O2. Okay. So now can you understand this problem? Say this A1, A2, A3. Position of the couplers. This is given. So from the three points A1, A2, and A3, you can find out where is O2. Similarly, from B1, B2, B3, you can find out where is O4. Okay, so the second step is uh, obtain O2 as the intersection of perpendicular bisector of A1, A2 and A2, A3. Okay. So, and similarly from B1, B2 and B3, we obtain O4. The problem become simple. You from this is really simple problem where we can go to the previous problem like this here. If I have this, and then if you just draw the perpendicular bisectors, they will give you this O2. And similarly, if you have B1, B2, B3, then you can get O4 here. Somewhere, according to the drawing, you can get this. Now the problem is in this kind of problems, due to some space constraint, and there are other constraints also be there, and due to that, the O4 and O2, the fixed points, would be they will be given. Initially, the O4 and O2, suppose those 2 points are given, and you have a choice to find out where is A1 and B1. That means the coupler position is given. Suppose the now problem, we are modifying the problem. Suppose the second type of problem, suppose the coupler position is given. Positions are given where A and B are not fixed. Okay. This is one thing given. Second thing, this O2 and O4 are also given. In this case, what we need to determine? In this case, what we need to determine? We need to determine this A and B. Okay. We need to determine A and B on the coupler. How will you solve that problem? Suppose this A and B, these 2 points are not given. O2 and O4 given, and the 3 position of the coupler is given. So, for example, suppose this point is O2 and this point is O4, and you have a coupler position given like this. This is the position 1. Suppose this is the position 1, and this is position 2, the same coupler, and this is position 3 of the coupler. Now, this 3 position of the coupler already given. O2 and O4 are the constant given. We have to find out where is point A and B on the coupler from these 3 positions. How to find out that? Here we need to determine. Bolo.
Draw a circle keeping O to a center.
Keeping O to a center, you draw a circle.
To get A.
Now, what should be the length of that radius of the circle?
That has to be calculated.
Now, suppose I draw a circle with respect to this O2, and it is passing through all the points. Okay, all the figures. In this case, it may not be passing, but suppose it is passing. Okay. But then how will you say that which point is a point on that circle, and that circle will pass through this these figures? But how do you know what is that point? Also, you need to ensure the position of B. So that problem is solved using the inverted motion. Okay, here I will use another software to show you what is a inverted motion, and from that how can we solve this problem. Okay, so I was working on it. Let me use that. This is actually the everything we can solve graphically. When graphical method, you are using pencil and paper, you have to use a trace paper and draw the inverted motions. Okay, so this is a figure we have already drawn, and I want to remove some of the lines from here to reduce the order of difficulty. So actually, let me remove this. Remove all those lines. And we will draw them again. This line we should not remove. Okay. All right. Okay, so this is a, just consider, can you see the cursor?
Yes, sir.
Yes, sir.
Yes, sir.
So
Yes, sir.
just consider this purple line. This is the first position of the of a four-bar linkage mechanism. For a four-bar linkage mechanism, can I do something? Let me see. All right. Okay. Okay, this is the position 1. Okay, now it is rotated in this direction, and this is position 2, and it is rotated further, it is rotated. So this green is the position 3. Do you agree with this? And I have just what we did, this link
Yes.
2 is rotating with respect to this O2. This is the point O2. With respect to O2, link 2 is rotating, and link 4 is hinged at this point O4. Okay, so from first position to second position, link 4 is also rotated to this blue one, and then from second to third to this green one. So what we have, you can see that link to the other point is on a circle, and link for the this one point is fixed and the another point is on this circle. So for them, the geometric conditions are satisfied. I have also taken care how this length of the coupler. Okay, so we have taken care that where should be the length. I mean, the length of the coupler is fixed here. Okay, so three position of a 4-bar mechanism is shown here. Do you agree with this? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
now we want to show you the inverted motion. We want to show you this is inverted motion of the mechanism with respect to link 3. Inverted motion means, suppose we have fixed this link 1 is fixed here, and you are rotating link 2 so that the link 3 and link 4 is also having motion. Now we want to say that just suppose I fix this link 3. I fix this link 3, and what will happen to the other links? Okay, so with respect to link 3, other links will also rotate. Now I will consider the same rotation. So link 2 is from position 1 to position 2. Link 2 is rotated this much. Okay, so after this rotation, this is the configuration of the mechanism in the second position. If we want this coupler fixed and do get the same rotation in link 2, what will happen? Just we will copy this second configuration and paste it on the first configuration, so that the link 3 position is exactly matching with the position 1. All right, and similarly for the third position also, what we will do, we will just copy this mechanism and paste it on the position 1, so that the link 3 position is exactly matching. For that, we will have some other position for O2 and O4. Okay, so the O2 and O4, their motion with respect to link 3 will be known to us. So those positions O2 and O4 are called the inverted motion, okay, with respect to link 3. Let's do that. So what we will do now, we will now copy this second position, and we will paste it. We will shift it to this first position, so that the link 3 will exactly match the position with link 1. Okay, so let's do that. So first we will just copy these 3 links we are copying, and we will move it to position 1. Okay, but in this moved position, you see that there is some angular difference between these couplers. So we will rotate it such that they will just match. Okay, so let me rotate it. I know how much we have to rotate, but for your case, what you can do, you can use the trace paper. Okay, a transparent paper you can use and mark these points and then move it. Not exactly matching, you see some difference is there, so you have to rotate it. Maybe this will, this may work. Okay, this is not exactly matching, and there is other reason. Okay, now you can see that position, we have copied the position to coupler, crank and follower on your trace paper, and then move the trace paper, place it on the first position so that the link 3 is exactly matching. After getting that match, now we have a new points O2 and O4. Okay, let us write down them here. So this is the new position. This is the new position of O2. This is a new position of O2. So we will call it O2 for the position 2, and it is inverted with respect to position 1. Okay. Similarly, this is a new point. This is a new point, which is again is a O4 inverted position of O4. So we'll call this point O. We'll call this point O4. O4 from position 2 inverted with respect to position 1. Okay. Now same thing we will do for the third position. To do that, first we will copy this. We'll copy the link positions. Okay. So we have selected now. We are copying it. So this copy you can make on your trace paper. Now what we will do, now we will move it to the first position. Okay, here I moved it to this position, and we have to rotate it so that this line must match with the previous line. Okay, and I'm just making it with this green color so that it is easier for you to understand that this is the third position. From here we have copied it. So now let us rotate it. This rotation, as I said, you will do with the help of your trace paper. So trace paper, it is very easy to rotate. Now I move it to this position. Okay. So after this rotation, we have a new O2 point. Let us write down here. So this point is now O2, and it is inverted with respect to position 1, but this is the third position. Okay, from the third position we obtain this, and now this is another point O4, which is O4 inverted with respect to position 1, and we have got it from position 3. So now you have two more points O2. So the three positions, for these three positions you have three. So first position is here only, O2. You can say this is, sorry, first position is, this is O2, A, B, O4. Second position is O2. Now we have moved all the points here. So we have these 3 points. Now you can see that with respect to this point, let's say A, and this point, let's say B, with respect to A, what is the inverted motion of this O2 point? This is the inverted motion. And you see, you know that we can also show you that if you join this point O2, O23, O22 and O2, if you join these 3 points, I can do it now. If you just join these 3 points, this point, and this point, and then you draw the perpendicular bisectors from O2, just I am trying to draw the perpendicular bisector. So let me draw it one by one. So now you see O2, O23 and O22. From here, if you try to draw the perpendicular bisector, so you will get this line. This is the perpendicular bisector, right? This is the perpendicular bisector of O2, O23, O22. Now, if I want to draw the perpendicular bisector for O22 and O2, what I should do? Let me remove this circle so that the less ambiguity will be there. I'm removing. This is the perpendicular bisector of O23 and O22. Now, if I draw a perpendicular bisector between O22 and O2, I'm drawing this circle and this circle. So they are intersecting at this point and this point. If you join, you will get the perpendicular bisector of this. Right, now again I will remove these lines just to keep the only perpendicular bisectors. So now you see that when you draw this perpendicular bisector and this perpendicular bisector, they are intersecting at A. Okay, similarly, if you draw perpendicular bisectors of O43 and O42, you will get this B point. O43, O42 and O42 and O4, you'll get this B point. This technique we will be using to solve this problem. Here, already this A point and B point are known to us. But suppose A and B are not known to us. Only the coupler at these 3 positions, the coupler is given to us. Then we can have inverted motion of this O2 and O4 point. After getting the inverted motion of O4 and O2 and O4 points, you can get this perpendicular bisectors and get this point A and B for this kind of problem where AB is not given. So what we will do to solve this kind of problem and to get A and B points, we will suppose this is our position 1. Suppose this is position 1, this is position 2, and this is position 3. So what we will do, we will now see what is the position of O2 and O4 with respect to second position. Then we will copy that and paste it on this first position exactly. So for that, this O2 and O4 will have some other positions here. Similarly, we will copy this third position, and with respect to that, what is the position of O2 and O4, then we will copy and paste it exactly on this. So for that also we will have O2 and O4 somewhere. Then we will join those O2 lines and get the perpendicular bisector that will be intersecting, those two will be intersecting somewhere here. That point is A, On the other hand, if you just join the O4 points and then get the perpendicular bisectors, they will intersect here somewhere. That will be point B. If you have questions, you can ask me. We'll continue this in our next class. So let me tell you about next class. Tomorrow the class will not be at 9:30. Tomorrow's class I will take some other day on this week because there is a webinar. So tomorrow's class will be on maybe Friday or Thursday. Okay. If you have question related to this, you can ask me.
Sir, uh, if we have assignments or exams in such questions, so should we use some software like AutoCAD, SolidWorks, or should we do it in paper?
You can use AutoCAD SolidWorks. I have no problem. But this is a paper. If you use paper, that is good. Just you need to manage some transparent paper. Nowadays, if you take a transparent sheet and if you use some marker on it or some kind of compass, that will be enough. If you can do it on AutoCAD, that is also fine. I have no problem. Uh, Purpose has to be solved. Okay.
Okay, sir. Thank you, sir.
If you have any other question, the recording will be available, and tomorrow I'll solve this problem. See, these methods are not very difficult. This is easy, but you need to practice. Without practice, you will forget everything. Today I am discussing whatever I have discussed. You just go and practice the same thing. You no need to read from somewhere, or if you don't want to practice, you need to read book. And obviously I am teaching from this book, Theory of Mechanisms and Machine. This book, Theory of Mechanisms and Machine. Okay, it is there. You can get the methods from this book. So in our next class on Wednesday, we will discuss this motion generation problem and maybe path generation. We'll try to solve. Then we'll go for function generation and dead center problem. With that, we will finish this dimensional synthesis. There are many things involved in this, but we'll not go into those discussions of all those things. I'll just cover these 4 topics I will cover here. Okay. All right. Thank you for your attention. If you have question, you can ask me. The recording is there. I will send you this PDF of the lectures. All right.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
So
Thank you, sir.
Thank you, sir.